Hello everyone. As we know that there can be two types of numbers which are possible. One are rational numbers and one are irrational numbers. So all the numbers which can be put in the form of p upon q, where q is not equal to 0, are known as rational numbers, while all the numbers in the under root which are not a perfect square. Here under root x is the irrational number where x should not be a perfect square. When I am saying perfect square, that means a number like 4, 9, 16, where we know that the under root of 4 is 2, under root of 9 is 3, under root of 16 is 4, is known as irrational number. Rational numbers have two different kind of format. One is terminating and the other is non-terminating but repeating decimal. Now this complete exercise is based on this logic. The first question is locate under root 10 and under root 17 on the number line. The first and foremost thing is we should understand that under root 10 and under root 17 are not the rational numbers because they are in the form of under root of x, where x is not a perfect square. 10 cannot be considered as a perfect square and 17 is also not a perfect square. So when we have to locate under root 10 on a number line, then we have to use the Pythagoras theorem. When I am saying Pythagoras theorem, we know that 3 square is 9 and 1 square is 10. If in case 1 square is 1, if we add the 2, it becomes 10. So on a number line where it is 0, 1, 2, 3, 4, 5 and so on. If on 3 we mark 1, this is from 0 to 3, it is 3. And from 3 to this point, we are marking 1 centimeter. So the Pythagoras says that the hypotenuse must be the sum of the square of base and perpendicular. So perpendicular is 1 and the base is 3. So the square of base is 9 and the square of perpendicular is 1. So this will come out to be under root of 10. This can be represented in two different ways. One is where on 3 I am taking 1 on the as a perpendicular. There may be a possibility that on 1 if I take 3 as the perpendicular, then also this line from O or from 0 to P point, it becomes under root of 10. Here also this is under root of 10. When I am talking about under root 17, so we have to break it up into two perfect squares. Like in the case of 10, we have broken it up into 9 and 1. In case of 17, we are breaking it in 4 and 1. The square of 4 is 16 and the square of 1 is 17. So 17 can be written as under root of 16 plus 1. When I am saying under root of 16 is the perfect square. When I am saying under root of 1, this is also a perfect square. Then on a number line, either taking 4 into consideration and from this 4 we take 1 above. So under root of 4 square plus under root of 1 square becomes under root of 17 square. So this will come out to be under root of 17. Another way is taking the base as 1 and taking the perpendicular as 4. Then also this distance will come out to be under root of 17. So there are two different ways of representing under root 10 and under root 17 on the number line. To these numbers we have to break up into the perfect squares. The second question is write the decimal expansion of each of the following numbers and say what kind of decimal expansion each has. These are already known to be the rational numbers because they are basically in the form of p upon q. As we know that they are in the form of p upon q, so this is clear that all these are known as the decimal expansion. Here, if I am solving 36 upon 100, it is 0.36. if I am solving 4 1 upon 8, so first of all we can write it as 33 upon 8, or directly we put this 4 and 1 upon 8 is 0.125. So directly I can write it as 4.125. 2 upon 9. If I solve this, now a decimal place, a 0, 9 to the 18. Again it is 2. I have to put a 0 in this. Again 9 to the 18. Now we are dividing. Now this thing will give 2 as the remainder. While putting a 0, again this thing will give 2 as a remainder. Again putting a 0, again this thing will give 2 as a remainder. So this remainder is never ending. This will remain 2 till infinity. And because the remainder keeps on coming, then this 2 will also keep on coming up to infinity. So here I can write 0.22 and dash. This means that the answer will keep on repeating itself, or this can be represented as 0.2 bar. This bar means that 2 is repeating itself infinite times. So this is known as non-terminating but repeating decimal. While in this case and this case they are terminating decimal, because after a particular point they are not repeating themselves. If I find a value for 2 upon 11, again if I solve it, it is point, taking 0, 1 jar 11, it is 9, again a 0, then 8 jar 88, then it is 2, again a 0, then 1 jar 11. Now this process will keep on repeating themselves. So 0.18, 18, 18 and so on. This can further be written as 0.18 bar. Here I am putting a bar on 2 terms because here both the values are keep on repeating themselves. So 0.18, 18, 18, 18 will keep on going as the answer. If I solve 3 upon 13 again, dividing 3 by 13, it is 0.0, 2 jar 26 will come out to be 4, 0, again 3 jar 39, come out to be 1, 0, again 0, it is 0 and keep on going. Now this will keep on going again till infinity. I am saying that these terms will keep on repeating themselves. If I solve this question, it is 329 upon 400. So this will come out to be 0.8225. And I am sure that this is a terminating decimal. Now, how to find out a number whether it is a terminating decimal or a non-terminating but repeating decimal? Keep one thing in mind that if in a fraction like P upon Q, the denominator has only the factors of 2 and 5, then it is a terminating decimal. If they have any factor except 2 and 5, then it is a non-terminating repeating decimal. Here it is 100, the denominator part. If I do the factors of this 100, it is 2 into 2 into 5 into 5. So we are clear that the factors are either 2 or 5. Here also the denominator is 8, means 2 into 2 into 2, either factor is 2. Here it is 3 into 3. So here the factors are besides 2 and 3. And when the factors are besides 2 and 5, when the factors are besides 2 and 5, any other factor, then it will come out to be a non-terminating but repeating decimal. So this and this are non-terminating and repeating decimal, while these three are terminating decimals. Thank you.